Thank you, Justin. Good morning, good afternoon, and good evening, everybody. Welcome to today's webinar, CFD is just not for experts. Before we dive in, we have plenty of people joining in still, so we don't want to showcase everything right away, but we have a couple of fun poll questions. So I would love for you guys to give us some feedback. See if you test your guys' knowledge, you know what CFD stands for, as well as we're gonna learn a lot about how easy it is to use this product, and then go through how we can leverage the data. So a couple of minutes, we have 3 poll questions, and then we'll dive in. I really hope nobody picks D. And tell who's picking what. Still, we have a lot of people joining. Our next question. We have a wide variety of people joining. So a lot of people are familiar with simulation. A lot of people use it here and there, and then some people are unfamiliar. And our goal today is to really just get a feeling of your experience. Excuse me. Another couple of seconds. This poll. We'll move on to our last poll. About another 50 seconds left of this poll. Still plenty of people joining, so we all understand for those people on the West Coast are fighting early morning traffic to get there for that 8 a.m. so much lunchtime for the people out here on the East Coast. And then for the people in Europe, it's probably happy hour time. So we appreciate you guys hanging out and joining us today. Just to share some results of the poll, for that first question of what is CFD, I'm happy to hear everybody picked traditional food. For the people that are on the call, we have a wide variety of everybody. Thankfully, nobody got simulation mixed up with CNC machining, which is fantastic. We have a lot of people that have experience in using simulation, consider themselves the analyst level, but still quite a bit of people that use simulation at least once a week or even a few. Times a month, and Great to see about 25% of the people on here that actually primarily spend their time in CAD and minimally use simulation. I think this will be a great fit for you guys. I think everybody's going to walk away with some great knowledge today from even the analysts, right, to see what Discovery Live is about. And of course, to our CAD guys, right, that know CAD like the back of their hands, but want to start dabbling around in simulation. And I think Tejas is going to do a phenomenal job showing just the ease of use and what we can really do with CFD. So with that said, let's go ahead and dive right in. Once again, for those who are joining, CFD is not just for experts. My name is Kurt Chan. We have Tejas Rao as well, who will be walking through the demo of the product. And let's talk about the agenda, right? The goal of today is how do you get started with CFD? How do you get started with ANSYS Discovery? We're going to showcase where you go to download it, where do you go to get help, where do you go to learn about tutorials. We have plenty of content. We have a great community here around ANSYS Discovery. And we listen to our community. We interact, myself, Tejas, we all live on our we call it the forum, and we interact with you guys, provide as many tips and tricks as we can. You probably hear our voices on all the videos that you see out there. We want to show you how you get started. Tejas is also going to walk you through what is interactive simulation. I think a lot of us are very familiar with meshing. We're very familiar with the traditional perception that simulation does take a long time to get a result, but what you're going to see today is all in real time, all live. We're not playing any videos whatsoever. You're just going to see Tejas go through, make changes, see things happen instantaneously in front of you guys. Also, we're going to talk about different use cases, everything from electronics enclosures to maybe fluids flowing down a pipe or HVAC. We have a couple different examples of how you can leverage CFD. And then lastly, the most important piece is what do you do with the data? How do you interpret the data? I think the most intimidating part to CFD or simulation in general is, well, what does this tell me? Then how do I apply it to my design change? And Tejas is going to walk you through all these different examples of how to leverage it. Upcoming events, just for a lot of you guys out there all over the world, what's coming up is the largest additive manufacturing show out in Frankfurt, Germany. I will be out there, so if anybody is out in Europe and plans to attend, please stop by the ANSYS booth. I would love to meet with you guys, shake your hand, chat simulation, and see how we can work together. If you are a current customer, please stop by as well. December 4th, we are doing another webinar. It's about how upfront rapid design exploration minimizes prototyping. Please join myself as well as one of our other senior application engineers, Waleed Raban. He will be on there as well, and we're going to show you how you can leverage another segment of ANSYS for design exploration. So where do you go to get content, and how do you download ANSYS Discovery? You can actually go to discovery.forum.com. On the very far right, you see download. That's where you're going to get access. You can get a trial there. If you're looking for tutorials, if you're looking for application examples, we have everything there. We just kicked off a great 2-minute quick tip video series. So every week we drop a new quick tip just on something cool inside of Discovery. So, I know everybody's always scrapped for time. You don't want to sit down and watch a 15-minute tutorial, and you just want some quick tidbits on exactly how to use the product. We are building that community and creating that content out there. So please check out our forum, and let's go ahead and go from there. So what is ANSYS Discovery? It's a breadth of different products, right? And when we actually look at the different phases here, and please let me know in the Q&A, if you hear any audio issues, please let us know. We'll do some adjustments on this end. There's going to be a recording, so hopefully things will come out well, but just let us know in the Q&A. So when you look at the product breadth here, we have design, explore, and analyze. And we're going to really focus on this explore phase because the explore phase is going to show us the instantaneous feedback of how we can leverage existing CAD data. So whatever CAD product you're using today, even if you have an STL file or a step file, we can bring all that in, leverage that existing CAD data, do quick design exploration, and then go back and finalize it in your CAD package. So Tejas is gonna focus on that. Just a quick typo, it's gonna be discoveryform.ansys.com for the form if you're looking for that, discoveryform.ansys.com, and I'll post that into the Q&A section so you guys have that as well. So what is CFD, right? And you guys know what is computational fluid dynamics. And when you start Wikipediaing what these definitions are, a lot of people get intimidated. A lot of people don't know what all these big words really mean. And the goal today is to show you just how easy it is to use CFD and how to apply it in all these different use cases, right? So we're gonna make this look as simple as possible, because it is as simple as possible to use ANSYS Discovery. Now, a couple of the different use cases we're going to talk about today. You can apply it with enclosures. You can do it with, this is an EGR valve from the automotive side, and then you can do some liquid cooling examples as well. So we're going to showcase a wide variety of everything. With that said, once again, it's going to be discoveryform.ansys.com. Please take a look at our form, and I'm going to hand it over to Tejas. Justin, please go ahead and hand it over. Thank you.
Okay, everybody. Can you guys, if you can hear me okay?
That's clear. Thank you, Tejas.
Okay.
Sounds great.
All right. Thank you. So thanks for the intro, Kurt. So everybody, this is just an introduction to this technology, and just to give you an idea of the kind of things that you can do with Discovery for CFD. As Kurt said, we have other sessions focused on other physics. Today we're going to focus on fluid flow simulation. So what you see is the Discovery tool, and this is what it looks like when you launch it. So I'm just going to show you what it does, just using some examples, okay? And hopefully this is interactive. You ask questions in the chat window, the Q&A window, and we'll do our best to answer them, okay? So first of all, I'm just going to import a file. And the first thing I want to point out is ANSYS has a long history of being CAD agnostic, and Discovery continues in this tradition. So you can import any CAD file. You can see all these different formats listed over here. Not only native CAD formats like CATIA and SolidWorks and NX, but also a bunch of neutral files. Okay, so that's the first thing I want to point out. So in this case, I'm going to start with a relatively simple geometry. It happens to be a step file. And this is what this geometry looks like. Not so complicated, but I think this does a good job of illustrating this technology. Okay, so let's take a look inside. Pretty simple. So let's pretend that you're a design engineer, and your job is to design a duct which takes air which comes in from the left and goes out through these two locations right here. Okay, so your job is to design a duct which tries to make the flow between these two outlets as uniform as possible. Okay, and the design challenge is that these inlet and outlet locations are fixed. You really can't change that. So you have to design the pipe in between the inlets and outlets to make this happen. Okay, so that's the design challenge. Now, traditionally, if you were designing this, you might come up with a design which looks something like this in your CAD system, whatever CAD system you have. And you might just prototype it or manufacture it. You might run a test on it and then find out after a long time and a lot of money that this doesn't work that well. Or you might pass it on to your colleagues in the expert simulation department, and they use ANSYS expert level tools, and they come back to you a day or so later and give you results, which is cool, but you still had to wait a couple of days. What if we could give you a tool which, with zero experience, you're able to visualize the flow inside this device, and it gives you really good insight as to what's happening, so you can make design changes intelligently. That's the whole purpose of Discovery Live. Okay, so now you can do this with traditional CFD tools, but the problem is they're very difficult to use. You have to be an expert. You have to learn how to use meshing and things like that. We have taken all that away from you, so you don't need to worry about those things. So let me show you how. So I'm going to click Create Solution. You can see we solve many different types of physics. Of course, we're going to focus on fluid flow in this seminar. And of course, I want to do an internal flow. And I'm just hovering my mouse over here, and you can see that's going to be an inlet. Okay. And you can see my outlet over there. If I hit Control, it switches. I can change directions. And there we go. Okay. And just like that, I have a solution. As Kurt said, this is not faked in any way. I'm running this in real time on my laptop I'm not running this on the cloud in some kind of supercomputer or anything like that. This is what it looks like. Okay, so let me just make it look a little bit cooler here. There we go. So now you can see, it's assumed a certain inlet velocity, but I can change that. Let's say it's 3 meters per second instead of 0.5 or whatever. And the moment I make a change to the inputs, I have my flow field being recalculated in real time. Now, you might be wondering, well, how is this happening? Well, we are using the power of the GPU. So we use NVIDIA GPU CUDA technology. And we have written proprietary GPU-based solvers which run on the GPU, which allows it to be so fast. But not only that, we have proprietary discretization schemes in the background that allow you to, which basically takes care of the meshing step for you, so to speak. Okay, so you don't have to worry about generating mesh and things like that. Okay. We also have very nice interactive post-processing, which you can see over here, which gives a pretty good idea to the user as to what's going on in this particular domain. So whether it's particle tracking, and of course I can launch this particle from a single location if I want, it allows the engineer to basically visualize on their computer what's happening in their particular device. Okay. So let's just take a look at other post-processing images. Okay. So now this tells me right off the bat that this is a pretty poor design because most of my flow is going down to the bottom area, right? Oh, by the way, I'm just going to look at some other different types of contours. So let's say we do that. So this is a cross section. You can see. So now you might say, well, how can I improve that? And you might have a design idea, which is to put some kind of splitter or a vein or something in the middle to see if that makes a difference. So let's go ahead and try that. Okay. So now, of course, you can use your native CAD tool to do this, but we also have built-in, let's say, rapid modeling tools, which allow you to quickly create geometry in a very informal way, and use this geometry to figure out what your design change should be before you do any kind of detailed design. That's the whole point. Okay. So you see here, I've designed a little piece over here, and what I'm going to do using these geometry manipulation tools is just kind of shove it in there. Okay. And you see, the moment I intersect that object with this duct, I have an update to my flow solution. I mean, this really illustrates the power of instantaneous simulation, right? Now, obviously, if you are creating a splitter, you wouldn't do it this way. You probably want to angle it like this, maybe something like this. And you can see how quick and crude I can be, to be honest, with my geometry in this tool. The discretization is extremely robust. You don't have to worry about intersecting parts or anything like that. And because we're solving on thousands of cores on a GPU, you get instantaneous results like you see over here. So now, once again, if I take a look at my maybe my contour over here, my cross section or my streamline, you can see what's going on. So now this gives me very quickly an idea that putting a splitter in there might be a good idea. Okay. Now, based on this, I might want to go back and design something in a more formal way and test that really quickly. So, let's pretend that I went off and did this in CATIA or SolidWorks or whatever, and now I have my new flow domain here, and I've designed something which looks like this. So you can see this is a little bit more formal of a design. And now if you wanted to test this little bit more finalized design, you basically say, well, I'm just going to go create another solution here, of course, internal flow, so on and so forth. And, even if you have to set up the problem from scratch, it literally takes you, 15 seconds to do so. The funny thing is the bottleneck now becomes just the transfer of geometry between your CAD tool and your simulation tool. So there you have it, a very quick demonstration of real-time CFD simulation, and gives you an idea of the kind of flow visualization and results you can get. Now, with this visualization, you might, a way to interpret this might be that, hey, with a single vein, I get this stream of fluid going up over there, which is nice, and yes, results like you see over here. So now, once again, if I take a look at my, maybe my contour over here, I'm sorry, my cross-section or my streamline solid, you can see what's going on. So now this gives me very quickly an idea that, putting a splitter in there might be a good idea. Okay. Now, based on this, I might want to go back and design something in a more formal way and test that really quickly. So, let's pretend that I went off and did this in CATIA or SolidWorks or whatever, and now I have my new flow domain here, and I've designed something which looks like this. So you can see this is a little bit more formal of a design. And now if you wanted to test this little bit more finalized design, you basically say, well, I'm just going to go create another solution here, of course, internal flow, so on and so forth. And, even if you have to set up the problem from scratch, it literally takes you, 15 seconds to do so. The funny thing is the bottleneck now becomes just the transfer of geometry between your CAD tool and your simulation tool. So there you have it, a very quick demonstration of real-time CFD simulation, and gives you an idea of the kind of flow visualization and results you can get. Now, with this visualization, you might, a way to interpret this might be that, hey, with a single vein, I get this stream of fluid going up over there, which is nice, but I still have this area which is not, properly resolved. So maybe I want to put a second vein over here. I want to adjust the flow geometry in some other way. You may want to look at things like, extending the inlets and outlets. I mean, all of these are now in the realm of possibility because you can check the impact of these design changes very, very quickly. The one caveat I do want to mention is that, we're not solving all the same types of high-end physics phenomena that you might be solving if you're an expert analyst using ANSYS CFD or whatever. So this is single phase, single species flow with, convection, heat transfer capabilities. And of course, you can't have any moving dynamic mesh or anything like that. And currently it's incompressible, right? So if your application fits these requirements, then this is something that you or your colleagues in the design team should be able to use very, very quickly. Okay. All right. Now, this is obviously a very simple geometry, and you're probably thinking, how does this look for a more complicated geometry? And let's take a look at that. So I'm going to open up this Egr assembly that Kurt alluded to earlier. It's a little bit more complicated. Let me change the color of this so that you guys can see it a little bit better. There you go.
And Tejas, just to field some questions in as you're
doing
them. One question that came up is, for that previous example, is does the solution get to steady state after a while?
Oh, great question. So as you probably noticed, that the solution, the solver in Discovery Live today is a transient solver, and I'll show you on this example. But you can turn on time averaging for the results so that your transient results are time averaged. That's one thing. I also want to point out that in our next release, which is 2020 R1 release, which is expected sometime in Q1, we will actually give you the option to have a steady state solver as well. So in the next release, not too far away, you'll be able to choose between a transient solver and a steady state solver and pick the one that suits your needs. Today, it is a transient solver, and of course, you can input monitors and things like that and see when your solution of interest flatlines essentially. or from a visual perspective, just turn on time average results, and I'll show you how that works for this example. Good question.
Perfect. Thank you so much. And just really quick, Tejas, it looks like the mic might have moved away from your mouth, so it might have sounded muffled a little bit. But just to reiterate, today is a transient solver. We're going to go into a little bit more detail around that. But tomorrow, we're going to have the steady state capabilities coming out in the next release.
That's right. That's right. And if my audio is bad, just let me know.
Yep. Sound great now.
Okay. So here's a more complex shape. I mean, this is something like a I have a couple of pieces floating around in space here. I'll delete that. So what we have is some kind of EGR valve. I mean, this is just a generic example, of course. And what we're trying to do here is have flow coming in through this inlet. And you'll also notice that we have a hot gas or inlet through here with this kind of valve controlling the opening. Okay. So once again, using our built-in tools, I mean, you can do these kind of manipulations really, really easily. Now, of course, you're more than welcome to do this using your CAD tool, but in case you don't want to go back to your CAD tool and make the simple change, you can certainly do it in here. Okay. So the goal of this simulation is, you know that this is the fully open position. Let's say I'm just making that up. And you want to understand what the flow distribution is with the hot gas coming in on the small opening and the cooler gas coming in on the main opening. Okay. And you want to see if you can somehow understand the mixing profile. Okay. Now, a couple of different ways to do this. Of course, you can go in and have it automatically create a fluid domain if you want. Or you can manually do it using our geometry tools that are available as part of this package. So you can see that we have a volume extract tool. It's very easy to do. I'm just going to pick these capping faces right here. Maybe provide a seed face. I'm going to preview the seed faces, and it goes off. And it's essentially, I'm just showing you kind of like how the sausage is made, so to speak, in terms of extracting fluid domain. So this looks nice, and I'm going to say, go ahead and create that body. Okay. So it's automatically created a fluid flow domain. If there was any kind of gap or leakage, the red colors would have leaked out, and I would have been able to use that to figure out where my leakage paths were. Okay. And I like to color my fluid domains this color. Now, let's say in reality you had another component which bolted onto this location, and that in reality your flow domain was longer, or you wanted to extend your outlet, which is a common practice. You don't have to go back and bring a new geometry in to extract that flow volume. I mean, I can just use the built-in geometry tools to just kind of pull this out to whatever length you want. I'm just showing you this to show you how the built-in geometry is used to complement your third-party CAD tool, whatever you're using or your colleagues are using. It doesn't have to replace that. But it's really handy to have these geometry tools in here to make these kind of quick changes. Okay, so let's go ahead and set up a solution here. So obviously we're doing a fluid flow. Once again, all these default material properties are available over here, and I'll show you how you can create custom properties as well. Now, obviously, we have already created a fluid volume, so I don't need to choose that. I'm just going to select the body, and it's going to be that body, okay? And then I'm going to proceed and apply my inputs and outputs, inlets and outlets, sorry. So one way I can do that, by the way, is to use this mini toolbar. You can see I'm going to do a flow velocity, and I'm just making up some numbers. 1 meter per second is fine. You'll also notice that it's available over here. So I'll do another flow velocity over here, and that is not the right direction. So let me do that again. Okay, that's much better. And I'll just pretend that this is coming in much faster, maybe 10 meters per second. Of course, I'm just making all these numbers up just to show you how this is done. And then finally, this is a pressure boundary condition. Okay, you can see all the different types of boundary conditions available over here. So we have flow velocity inlet, kind of a swirl, a mass flow, inlet pressure, outlet pressure, rotating walls, a slip boundary condition, gravity for natural convection, and so on. Now, like I said, I want to investigate not only the mixing of the flow, but also the temperature. So by default, it's going to assume the flow coming in on this big face is 20, degrees Celsius, but here I'm going to apply a thermal condition, which is a temperature, and let's just make something up. Let's say this is 150 Celsius, you know. So that's pretty much it, right? And I just have to click solve, and off we go again. Okay. Just like before, instantaneous real-time simulation looks pretty cool. By default, we make all the solid bodies kind of transparent, as you can see. And you know, let's start looking at some post-processing. So of course, we can do that. We can take a look at this kind of cross-section. We can manipulate this any way you want. You know, dynamic manipulation of your CFD results are also very important to us, you know, because we want the target engineer, the design engineer, to be able to look at this and be able to immediately see what's going on. You know, think about it as a very fast flow visualization tool rather than a high accuracy instrument like your expert level tool. Okay, so you can see here. Yeah, go ahead. Was there a question?
Yeah. Sorry. Yeah. So around, you know, seeing the fluid mesh or seeing the mesh here, and you know, the perspective, and you can share your thoughts on it. Is just as you described it. This is here we are getting quick results on what's going on. What if we did this? What if you changed the temperature? What if you did that? Right.
Right.
So
exactly.
You can talk about the accuracy part of it, and part of the ANSYS Discovery portfolio, we have a higher accuracy product there, but with the Discovery today is this. Go ahead.
Yeah, so that's a good question on accuracy, right? And certainly this tool is not intended or cannot today give you the same level of accuracy, especially from a fluid flow perspective compared to a fluid or EFX or what.
It just looks like you're moving away from the mic. If you could just move a little bit closer.
Okay, is that better?
A lot better, yep.
Thank you. So I was just saying that, you know, the goal here is not to match the accuracy you have in Fluent or so on, but get as close as possible. Now, having said that, as you guys know, you know, mesh is very important, right? So what's happening behind the scenes? What's happening behind the scenes is it's taking the fluid domain, discretizing this domain, basically using voxels, right? We use a voxel-based GPU solver. Now, the resolution of those voxels depends on two things. One is this slider bar that you have here, and this is the default setting. And if I move the slider bar to the right, what it does is it uses more GPU memory to basically generate even finer voxels everywhere in the domain. Now, you might be wondering, hey, why don't you show the mesh? Now, this is something that we have done strategically. We could show the mesh. But think about the target audience. The target audience in our mind are people who don't know about meshing. And showing a mesh doesn't necessarily help them. It helps the expert user, like the person who asked this question maybe. So we're trying to think of other ways in which we could show the level of discretization. One way we are trying to do it, and this is a new feature in the current version, is if I hover my mouse over here, you can see it tells me the minimum geometry size that is currently being resolved. Not only that, I have a little, I hope you can see that, a little ruler which shows you what that looks like. And if I zoom in, you can see the discretization that's happening, right? If I crank this over to max fidelity, you know, you'll see what happens with the level of discretization, right? And of course, the smaller the element size, the better the result is going to be. Now, the goal here is to give you overall flow distribution. It's today, things like pressure drop and so on are not predicted with the level of accuracy that you might expect as an expert user. But the goal here is to give the design engineer an idea of what's happening with the flow field. Now, some of you are probably thinking, well, if you're not discretizing the wall very carefully, how are you going to capture separation properties? Like that. And that's a great question. If you have an external aerodynamics case where you're looking at flow separation points on top of an automobile or something like that, today the software will
move a little closer. Sorry. Yep.
Yeah. Today the software will not capture that accurately. So it is important to target the right application with this software, especially for CFD. And this is something that my team is more than happy to help you guys with. We are working on techniques to automatically have a lot more refinement in areas near the wall for all the obvious reasons. But do this in an automatic way so that the target user, which is the non-expert, does not have to worry about it too much. Okay. Hopefully that answered some of your questions. Let's take a look at more results. So now you see, my transient results. By the way, there was a previous question about results displayed. So you see if I turn on time average result display, you can see that it starts to average itself out. Okay. By the way, I also have lots of calculators. So for example, if I wanted to calculate, let's say average temperature on face, and it's this face, okay, you'll see what that looks like. If I turn off time averaging, you'll notice that the chart kind of starts oscillating, okay, and you start getting. Okay, sorry. Can you guys hear me? Sorry.
Yeah, you sound great. You sound great.
Yeah. So a couple of people, I apologize for the audio if you can't hear it. So you can see what happens when I turn the time averaging on and off, right? So the speed is very fast. It's the geometry resolution that is impacted by GPU memory. So if I have a 16 gigabyte GPU like I do, and I crank my fidelity slider all the way to the right, I might get a feature capture of, let's say, 0.5 millimeter. If you have a 4 gigabyte GPU and you crank the fidelity slider all the way to the right, you might only capture 2 millimeters of geometry. So depending on the type of application you have, that may or may not be good. So this is a question that you should consider, and hopefully you're able to acquire GPUs that satisfy your requirements. Once again, having said that, we are working for our next release on much more efficient memory allocation on the GPU so that you will be able to use or obtain significantly higher level of discretization even with the same GPU that you have. So stay tuned for that information. Okay. So here's an example of mixing. Temperature mixing is a very nice application for Discovery Live. We see it a lot, let's say, in kind of architectural and building examples sometimes, where you want to see flow distribution, temperature distribution, and so on. Okay. So I have one more example that I'd like to share with you guys, maybe two. This one is an enclosure that I want to show you. Another thing I forgot to tell you is from a thermal perspective, we do obviously have temperature boundary conditions, but we do not account for conjugate heat transfer, if that's something you're interested in. So we do not do CHD yet. But this is in the roadmap. So here you can see we obtained this geometry from somewhere, very, very detailed geometry, right? And obviously to get a right answer in terms of temperature distribution on these electronics components, you need to do a conjugate heat transfer problem, which you cannot do today. But what if the designer wanted to understand the general flow pattern inside here? That's basically what we're trying to determine, right? So once again, let's go ahead and set up a CFD simulation. So we have the flow body, which is just a rough box which represents the domain. You don't have to worry about meshing and so on, or detailed flow volume extraction, because it handles all the internal bodies at the solver level as opposed to the geometry or mesh level, if you know what I mean. I have to stop sharing for 1 second. Sorry.
And it's great to see all the engagement going on right now in the question and answer. So a lot of questions coming in around hardware. A lot of people have some great hardware. You have that NVIDIA, the NVIDIA card, no problem whatsoever. As a lot of questions asked around transient or steady state. As Tej just mentioned, once again, he was showing transient. Steady state is set to debut in the next release. And as we, Tej, one question came up too is, a couple guys on here say, hey, they have multiple GPUs. So can you leverage multiple GPUs today, or is that in your plan?
Not today. So what it does is, if you have two GPUs, what you can do is you can split up the rendering and the computation on two GPUs. But to be honest, you're not going to get that much of a speed up, right? So we did have a thought on how to do multi-GPU, and we decided to focus more on much better memory allocation on a single GPU, because we feel that will provide the user with the most value, right? Because GPUs are, while they're getting more and more common, they're still, they cost something. And, buying two GPUs is more expensive than buying one. So we want to try to make this technology really accessible to everybody. And so we're really focusing on making the memory utilization on a single GPU, as good as possible, right?
Yep.
So just to show you, let's say, you had this and you wanted to, make this bigger somehow, and you wanted to find out, hey, if I make this bigger, how is that going to impact my flow inside the domain, right? And you can see, as soon as I make that change, and this is really incredible, right? You start to see the impact on the solution, right? And of course, you wait a little bit so the flow settles down, or you use a transient solver that's coming up in the next release. And see, we don't even care if these parts are intersecting or anything like that. I mean, I can literally move this to any position I want, and it will start solving again. Because this, the Boolean of the geometry with the fluid domain is happening at the mesh level, at the numerical level, not at the physical geometry or mesh level. So I'm just using this to show you the technology that we have debuted in this tool. That is very exciting, because this is just the first generation. Like I said, there are many improvements which are coming, but it lays the foundation for anybody, even with no meshing or CFD experience, to be able to visualize the flow in real time and be informed of what's going on, so that they can make, intelligent product decisions.
And Tej, just to that point, I know we have about 5 minutes left. We can answer some more questions, but something to keep in mind too is, according to our polls earlier, we had about 30% of the people on here that strictly just use CAD. So think about from a CAD perspective, somebody that's not familiar with simulation, as you said, hey, I'm unfamiliar with meshing, I'm unfamiliar with doing the, taking it to that level. I just want to get a quick result. I want to make sure I'm going down this correct design process. Is my design going to even work? Is it going to withstand this structural, or can it withstand these different fluid domains? So that's the goal here, right? Is we're here to get quick quick feedback on exactly, are we going down the right path, right? And for the people on the call that were 30% analysts, right, that are on here, hey, look, imagine having the designers that might have this tool in their hands, and they can quickly get an idea if they're going down that right path. And now they can come to you and be like, hey, look, here are my now final 2 designs. I need your expertise to tell me, rather than come back with 10 designs. Hey, so just keep in mind the end goal here for who we're targeting to use it.
So, of course, we don't recommend you do fancy external aerodynamics, but if you wanted to please your kids or impress your colleagues, it's even easier to do with Discovery.
You're now giving me some interesting marketing ideas with Superman.
Yeah. So there you have it. I mean, I hope this gave you an idea. Once again, I want to emphasize that this technology is still very new. We're very excited about it, and this seminar is really to inform you of this technology and make sure you are aware of what's out there. But there are still lots of caveats and lots of details. So we welcome you to contact us, and I know, Kurt, if you can throw up your final slide with the contact information or whatever.
Yep.
We welcome you to contact us, and we are more than happy. I have a team of people